Once we know our two molarities on the left side, we can determine whether the solution is acidic or basic. If the hydroxide molarity value is greater than the total solution is basic. If the hydrogen molarity is greater, then the solution is acidic. Our previous example is acidic because the hydrogen molarity is greater than the hydroxide molarity. But what about the actual pH or pOH? Calculating the actual pH or pOH of a solution requires another formula. The pH equals negative log of the H molarity. This can also be written as the molarity of H equals 10 to the power of negative pH. Thus, the absolute value of the exponent in scientific notation is the pH of that solution. It is also important to note that with these formulas, H3O+ may be written as simply H+, but these both refer to the molarity of hydrogen ions. The same formula can be used to find pOH. Simply replace pH with pOH and hydrogen with hydroxide. Let's do another practice problem. What is the pH of a solution that contains 25 grams of hydrochloric acid dissolved in 1.5 liters of solution? This may look complicated, but we have all the information we need. Molarity is moles over liters. We know that we have 25 grams of hydrochloric acid, so we can use dimensional analysis to determine the number of moles we are given. We also know, as we learn with the unit over acid nomenclature, that hydrochloric acid has a hydrogen bonded to a chlorine, HCl. The molar mass of HCl is 1 hydrogen plus 1 chlorine. This is 36.46 grams. We can use dimensional analysis to find the number of moles from here. From here we simply calculate molarity, 0.69 moles over 1.5 liters. This is 0.46. Now we can use our previous equation, pH equals negative log of molarity. The negative log of 0.46 is 0.34, with the appropriate significant digits. Thus, the pH of the solution is 0.34, making it very acidic. Remember that we can also write logs as exponents. This could be helpful in questions where you are asked to find the molarity if given the pH. For example, what is the molarity of a perchloric acid solution with a pH of 1.45? We can write this problem like this with the log. Because this is an implied log 10 of x, we can change it to this, just like the other formula. All we have to do now is solve. Another important note is that the pH value plus the pOH value is equivalent to 14. For example, if a solution has an H molarity of 10 to the negative 3, then we know that the pH is 3 based on our previous equation. We also know that the pOH is 11 because 14 minus the pH value, or 3, equals 11. Let's check to make sure. Based on our kW formula, we know that the molarity of H multiplied by the molarity of OH is the constant 10 to the negative 14. Let's plug in what we know. The H value is 10 to the negative 3, the OH value is unknown, and the constant is the same. All we need to do is solve for x, which, as expected, has an exponent of negative 11.